Okay, question about the preparation of salts. Here we go. So, the first bit, we just have to say whether these three salts are soluble or insoluble. Ammonium chloride, lithium sulfate and magnesium carbonate. Now, there's no other way to do this than just sit down and learn whether these three things and many other salts in the syllabus are soluble or insoluble. And it's difficult, you know, it's boring and it's not easy to remember, but unfortunately you've just got to do it for your exam, okay? So you just have to learn that ammonium chloride it's soluble. Oh, this is in water, by the way. Could be a different solvent, but we're talking about water here. Ammonium chloride is soluble in water, lithium sulfate is soluble in water, and magnesium carbonate is insoluble in water. Okay, like I say, it's boring to learn, but you've got to do it. I could never learn these easily, it never stuck. I still don't know them, I have to look them up. But you're going to have to do it for your exam. Okay, next bit. Okay, we're making some lead sulfate here, the salt, and we're told that the theoretical yield is 2.85 grams, the actual yield is 2.53 grams, and the percentage yield is what we have to work out. Okay, well, that's no problem. It's a percentage. You do that when you're what, 11? So we should be able to do this. Percentage yield is actual over theoretical times 100. So 2.53 out of 2.85 times 100. Stick it in your calculator and you get 88.7719 something something something. We have to give this for two significant figures. So that's 7 pushes that 8 up to a 9. So that's 89% to two significant figures. Piece of cheese. Right, next bit. They give you a method which is used to prepare lead sulfate. Okay, now I'll read out the method. It's a suboptimal experimental procedure. We're going to improve it, and the question is what you have to do to improve it, essentially. So what they do, they pour 100 cm cubed of lead nitrate solution into a beaker. Okay, it's this reaction here. They add drops of sodium sulfate until a precipitate is seen. They allow the precipitate to settle to the bottom of the beaker. They pour off the liquid and they use a spatula to transfer the solid lead sulfate onto a filter paper. The precipitate is the lead sulfate, the thing you want, because lead sulfate is also insoluble in water. Okay? Right, the question. Explain 2 ways of improving this experimental method to increase the amount and quality of lead sulfate obtained from the same volume of lead nitrate solution. 4 marks. Okay, now it says it wants 2 ways, but I'm going to list everything that you need to know because you need to know it. But, you know, for the exam you just have to pick 2 ways. Okay, so the first thing they do, they pour 100 cm cubed of lead nitrate solution into a beaker. That's fine. Then they add drops of sodium sulfate. Okay, so that's in the beaker. They're adding sodium sulfate until a precipitate is seen. Okay, we can improve that. Don't stop adding the sodium sulfate when you see the precipitate. Keep going, add an excess of sodium sulfate so all of the lead nitrate reacts. Okay? So say what you're doing and why you're doing it. Don't just say what you're doing, okay? So what you're doing, why you're doing it. So what we're doing is adding an excess of sodium sulfate, and we're doing it so all the lead nitrate reacts. Okay? Let me just explain what an excess is. An excess of something means that you add more moles of this than there are of that, okay? Because we want all of that to react to get the maximum yield, right? And you do that by making sure there's enough of this to go round for all of the molecules of that. So an excess means there's at least as many of them as there are of that. Technically speaking, at least as many moles of them as there are of that. A mole is just a number, like a dozen, for example, but it's a bit much bigger than a dozen. So another way of putting it would be there are at least as many molecules of that in the reaction solution as there are of that. Okay, that's what an excess is. All right, moving on. Right. The next thing they did was to allow the precipitate to settle to the bottom of the beaker. No need to do that. And then they poured off the liquid. Okay. Much better to wait a little while, stir it so it's all reacted. Yeah, I can say that. Stir. Okay, to leave it a while, a few minutes. I'm not quite sure how fast this reaction goes. So if you don't know that in the exam, you may not get marks for what I'm going to write here, but I'll write it in just in case. No harm in saying too much. Stir. Maybe say something like until all the lead nitrate is reacted, and then leave to settle. But that's not super important, okay? The important bit is that once all the lead sulfate has precipitated out of solution, the important thing is that you pour it through filter paper, okay? Pour the mixture through filter paper. I think I'm going to need new pens soon. Okay? So, say what you're doing, why you're doing it. The reason you're doing it is because you want to make sure you isolate all of the lead sulfate, so you don't leave any behind in the beaker. So none of the lead sulfate is left in the beaker. Okay, which it would have been if you did how they suggested it, which was to allow it to settle to the bottom, decant off the liquid, and then use a spatula to dig it out. That's a very naff way of doing it, okay? Some of it, quite a lot of it is going to be left in the bottom of the beaker. You can't dig it all out with a spatula. Okay, so you pour it through a filter paper. Good. Now, at this stage, we have why not? We have some filter paper, okay, in a filter funnel, which will be in a beaker, okay, and our lead sulfate will be in the filter paper, okay, so that's the lead sulfate. And the rest of the mixture will have gone through the filter paper into the beaker. Okay, so the next thing to do is to wash the lead sulfate with some distilled water. Okay? Now don't worry, it's not going to dissolve because it's insoluble, remember? Lead sulfate is insoluble. It's why it precipitated out of an aqueous solution in the first place. So we wash with distilled water. say what you're doing and why you're doing it. It's to remove impurities. Okay, to clean the lead sulfate. Okay, and the last thing we should do is, so now we've got pure, cleaned lead sulfate, but it's a bit damp because we've just washed it. So you place it in a drying oven. Because that will give you, so what you're doing, why you're doing it. You'll end up with dry lead sulfate. And that's it. Okay, so that is the correct experimental procedure for making a salt, getting as much of it as you can, as large as yield as you can, isolating as much of it as you can, making sure it's pure and dry. That's the correct experimental procedure. Okay? You always have to wash it. Well, first you send it through filter paper, then you wash it, then you dry it in an oven. Excellent! And that will do. Okay, final question. Ammonium nitrate is produced from ammonia and nitric acid on a large scale in industry. Here's our ammonia, here's our nitric acid, and there's ammonium nitrate. Ammonium nitrate can also be made in the laboratory by titrating ammonia solution with dilute nitric acid. Same reaction, different method. Ammonium nitrate crystals can then be obtained by evaporating off some of the water from the solution. Give 2 reasons why this method is not suitable for use on a large scale in industry. Okay, 2 marks. So what they're doing, they tell you 2 things that this method involves in the lab, okay? So that's what you must focus on. They firstly tell you that ammonium nitrate can be made in the lab by titrating ammonium solution with dilute nitric acid. Okay, so there's something about titrations that we can get a mark out of, right? And that thing is that, well, titrations are quite simply totally unsuitable for use on a large scale, okay? Titration's all about titrating in accurately the correct volume of liquid, and doing that on a large scale means you'd be having to add, to get it done in a reasonable time, having to add large volumes each time, which is, so it'd be difficult to do it accurately. To do it accurately, it would take you forever. Okay, so the point is that titrations are not suitable for a large scale. For large scale. Okay? The volumes of liquid are just too big. And the second thing they mention in the question is that ammonium nitrate crystals can then be obtained by evaporating off some of the water from the solution. Okay? So that's where we're going to get our second mark. Again, this is totally unsuitable for large scale. Evaporating off water is fine in the lab. On the small scale, it doesn't take too long, but on the large scale, you'd have to evaporate off huge volumes of water, which would take an awfully long time, okay? And it's impractical anyway, and probably expensive. Not that water's expensive, but it's impractical, okay? So, kind of the same thing. So evaporating large volumes of water is impractical. Water is impractical at the large scale. Okay? Good, that's it. That will get you your 2 marks. Just briefly, this method, of evaporating water to obtain crystals of your product. Let me just make sure you understand what's going on there. Ammonium nitrate is highly soluble in water, so crystals of it are obtained by, you've got your container of some sort, okay, and the water and the ammonium nitrate dissolved in the water. If you evaporate off the water, okay, you still have the same amount of ammonium nitrate crystals in the water, but the volume of water, the amount of water is decreasing as it evaporates, which means the concentration of the ammonium nitrate in the water is increasing, and eventually it gets to the point where the concentration is too great for the water to hold it. It can't, or there's too much ammonium nitrate to dissolve in the amount of water available, and that is the point at which crystals start to form, and the crystals grow and grow as the water evaporates. Okay? It's a method of obtaining your product when it's soluble in a solvent. There are other methods, but that's the evaporation method. Okay, we're finished.